absolute value of A is equal to 0 if and only if A is equal to 0 itself. Okay. Other numbers, A positive, absolute value is positive. A is negative, the absolute value is still positive, only 0. And in here, you see that I gave you the whole number, but actually you can have a decimal fraction, say absolute value of 3.7 is equal to 3.7. Okay. Absolute negative 1.2 is equal to plus 1.2. Okay. So the first property right here is saying what? The distance will never be negative. Means what? Always non-negative. Could be positive or 0. Okay. And the only case that you have absolute value equal to 0 is that number is 0 itself. The distance from 0 to 0 is 0. Okay, that was the first property. You guys can compare this property to the A squared thing that we just learned in the previous section. Okay. Now, we're going to talk about another property of absolute value. About property number 2. Okay. We have absolute value of A. Okay. And we have 2 cases for A in here. That means 2 cases. Okay. If the number A right here is positive or 0, if A is greater than or equal to 0, then absolute value of 8 is equal to A itself. Then absolute value of A is equal to A. You see why? It's the example right here. If you have a number that's positive, or even 0, and absolute value of 3 is 3, absolute value of 5 is 5, absolute value of 0 is 0, that pointing inside the absolute value is non-negative, then of course the distance is positive, this is non-negative, the distance is non-negative. Good. And then the other way around, if the number inside is negative number, A is less than 0, then what happened? Say absolute value of negative 5. Now A is equal to negative 5. Then absolute value of negative 5 is equal to what? It's 5, right? The distance from negative 5 to 0 is 5. A is negative 5. The answer is 5. What? The answer, the distance right here, of the absolute value right here, is going to be the opposite of A. Then absolute value of A is equal to negative A. Now, I know that many people may confuse that. You say that the absolute value will never be a negative number, but why did I put a negative sign right here? And what do I mean by that? Negative right here means the opposite of A. And keep in mind that A itself is already a negative number. Okay? A is negative 5 in this example. So if you put another negative in front of negative 5, what do you get? Double negative, make it a positive number. Okay? So what it's all saying is what? The absolute value of a negative number is the opposite of a negative number, which means it's going to be a positive number. Okay? So if you know the quantity inside the absolute value is positive, then you are safe to take off the absolute value because it's the same. If you know that the quantity inside the absolute value is a negative number, then you want to take out the absolute value, you put a negative sign in front of the quantity inside the absolute value, and you can solve. And now that you don't have the absolute value anymore. Okay. Example. Okay. You're solving for absolute value, right? Example for solving for equation. Okay. Example. Solve for x. This is what I got. Absolute value of x is equal to 3. Okay. What x could be? Many people say right away, oh, x equal to 3. That's good because absolute value of 3 is equal to 3. But is it the only solution? The answer is no. It's going to have one more because you ask yourself, what number is going to distance to the origin equal to 3? See, by definition, absolute value of x equal to 3 means what? This is 0 right here. This is x right here. The distance from x to origin equal to 3. But It's not only one x, I got a distance to the origin equal to 3. I may have another x on this side. I got a distance to the origin equal to 3 as well. The distance is 3. And this x is equal to 3. And the other x is equal to negative 3. Okay. So there are two values of x that make the distance to the origin equal to 3, which is x equal to 3 and x equal to negative 3. So you guys are going to have two solutions, either x equal to 3 or x equal to negative 3. Okay? Try one more example. How about this? Make it a little bit more complicated. Absolute value of x minus 2 equal to 3. Now, pay attention. The quantity inside the absolute value may not be a simple x anymore. It could be a complicated thing. Now we are talking what? The distance from x minus 2 to the origin is equal to 3. Okay? So we have this, the origin right here, right? So the number inside the absolute value is not x. We're talking about what? X minus 2. X minus 2 is somewhere right here. And the distance from x minus 2 to 0 is equal to 3. So we have either x minus 2 equal to 3 if x minus 2 is on the right hand side. But we also have one more position, one more point that have the distance equal to 3 to the origin from the origin. So if x minus 2 on the left hand side of the origin, then the distance is still 3, right? It's from here to here is still 3, the distance. And you have the second equation is what? X minus 3 equal to, minus 2, I'm sorry. Minus 2 equal to negative 3, okay? So if this point right here is negative 3, this point right here is 3, you have two equations, right? X minus 2 equal to negative 3. The absolute value of x minus 2 is equal to 3. See, absolute value of x minus 2 equal to 3. Absolute value. Okay. The absolute value of x minus 2 is still equal to 3, right? So two cases. And the good thing is, I'm getting rid of the absolute value. Now I can solve for x from the two equations right here. Okay? Well, add 2 on both sides. I got x equal to, add 2 here, add 2 here. Negative 1, you got what? X equal to 5. Okay? So you actually have two solutions in this case. And the main thing that I try to emphasize is what? Whenever you have an equation involving inequality, say absolute value equal to a number, of course if that number is negative, you have no solution because based on the definition, distance can never be 0. Okay? If absolute value equal to 0, it's right here, you have one solution. Negative 0, positive 0, stay the same. Absolute value is positive. And I bet that many, I would say, many people are going to forget the left-hand side right here. Always say, well, x minus 2 equal to 3. Let that not be enough. Make sure that you understand the definition of the meaning of absolute value, right? And you see what? The distance from x minus 2 to the origin equal to 3. So x minus 2 could be equal to 3. You have a solution. Or x minus 2 could be equal to negative 3. And you solve, you have another solution. Okay. Let's move on to another exercise involving absolute value, but this time I'm going to be talking about inequalities. Okay. I think I should give you another example. I think this. Let me give you one more example before I move on. Okay. Make the example becomes more complicated. So when you guys see your homework, it's going to be easier for you guys to practice. How about another soft X? I got this. 2 times absolute value of 3 minus 2x minus 5 equal to 1. I'm just making it up. All right. So it's not just absolute value equal to a number. I give you a big mess equal to a number on the other side. Okay? So we have to simplify, make it just an absolute value equal to something. And of course, simplify what? First of all, add 5 on both sides. I got 2 times absolute value of x minus 2x. Add 5 on the left, add 5 on the right. You got equal to 6. Now divide both sides by 2. And you know what? Actually, you can distribute that 2 to the 2 term multiplied in, but I think dividing is better. Okay? 2 ways. Here what? 3 minus 2x. I'm going to divide both sides by 2. Divide both sides by 2. Both sides by 2 equal to 3. It's the absolute value in here. All right? Now, you have absolute value on the left-hand side equal to a number on the right-hand side. You're okay to go back to the previous example and work. You're going to get rid of the absolute value, make it 2 equations. The distance from 3 minus 2x to the origin equal to 3. That means what? Either 3 minus 2x equal to 3, right? Positive sign, or 3 minus 2x equal to negative 3. And you guys can solve x from here. Let's solve this one first. Subtract the 3 on both sides. Negative 2x equal to negative 6, right? Minus 3 minus 3, negative 6. And divide both sides by negative 2. X is equal to 3, right? This one right here, subtract the 3 on both sides. I got negative 2x equal to 0. Divide both sides by negative 2. X equal to 0. See that you have 2 solutions. Okay. And I planned, actually, I was planning to stop right here in this example. But at the last minute, I changed my mind. I think that gives you more examples. Okay. Could be more complicated to help you to see through the sections, the use of absolute value a little bit deeper. See? You have a big mess trying to simplify. Eventually, you get to absolute value equal to a number, and the key is what split it up, okay, to inequality. And try to understand. If you have any question, feel free to ask me. You just try to memorize the trick, and then you may get confused later on because there are many things to know. Okay, let me move on. Another example, but now instead of talking about equations involving absolute value, we talk about inequalities. Okay, involving absolute value. So I'll make it like problem number 3. Let's start with an example then. Solve with something like absolute value of x, say, less than 3. Somehow I keep sticking with number 3 all the time, but any positive number. Okay, solve for x. Solve for x. Solve for x, okay? You look for all the value of x that's less than 3. Okay, so I think it'd be easier if I use the number line to demonstrate the value of x. This means what? By definition, the distance from x to the origin gotta be strictly less than 3. So the question is, what value of x can we have so that the distance gotta be less than 3? Okay, the origin right here. And the distance from x to the origin less than 3, so where can x be? Can x be here? Yeah. X will be here, yeah, 3 is 1, 2, and 3, right? X is at most goes to 3, but less than 3. Gonna be a little bit less than 3, right? So x can go all the way, if you go to the right hand side, all the way to 3, a little bit less than 3, say 2.999. But that's not the only thing that x can go. X can even go to the left, right? Because we're talking about distance. X could be right here, and the distance to the origin is less than 3. Similarly, all the way to this is 0 right here, negative 1, negative 2, negative 3 right there. And the distance is strictly less than 3, so we cannot include a negative 3. Right? So in this example, x could be anything between 3 and negative 3, and excluding the endpoints. See? X could be negative 2, absolute value of negative 2 is 2, less than 3. X could be 2.5, absolute value of 2.5 is 2.5. X cannot be 3, x cannot be negative, anything in between. So the answer for this problem is what? Negative 3 less than x, less than positive 3. And for interval notation, you guys may use parentheses, negative 3, comma 3, parentheses. Okay? And let me move on to another example. It's a little bit more complicated. How about this? Absolute value of x minus 2 to be less than 3. Now see what? The number inside the absolute value is not x anymore. It is now x minus 2. So we don't talk about the distance from x to the origin anymore. this example right here, we're talking about the distance from x minus 2 to the origin to be less than 3. We're going to solve the same way in here. So this is not x anymore. This is going to be what? X minus 2, right? Somewhere in here, x minus 2. So we have what? X minus 2 going to be somewhere between negative 3 to positive 3, right? The distance from x minus 3 to the origin is less than 3. Okay? And then this is actually two inequalities. You see it, but in this case, we can combine the two inequalities to solve that one. What are you doing here? Add 2 on both sides. You have the answer. On 3 sides, actually. Add 2, add 2, add 2. You got negative 1 less than x and less than 5. And of course, interval notation is parentheses, negative 1 comma 5. Okay? So, if you have absolute value of something less than a positive number, you're going to get rid of the absolute value by putting the quantity in between the negative and positive of that number. Less than 3, or negative 3 less than x less than 3, right? Absolute value less than 5, and negative 5 less than x less than 5. You can solve. Okay? And this may not be just said, this may be a big complicated thing, like x minus 2, or 3x minus 1 over 2, anything. You solve the same way. Okay. Now I'm going to talk about another inequality, but this time instead of less than, talk about what? Greater than. Oh, by the way, when anything works with less than, it's going to work what? Less than or equal to. Do the same thing again. Less than equal to, less than equal to. And instead of having the parenthesis, now what? You change to square bracket if it's less than or equal to. Okay. Probably number 4 then. If you got, say, it's still solve for x. If I got absolute value of x is greater than 3. Now this one is less than, right? This is greater than. Be careful. The way we tackle it is going to be a little bit different, okay? And to help us understand it a little bit easier, let me demonstrate the inequality on a number line. Origin right here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Negative 1, negative 2, negative 3. Negative 4, negative 5, and then this line's going this way. Okay. So, according to our definition, we say what? Absolute value of x greater than 3 means the distance from a number x to the origin is bigger than 3. Okay? So, bigger than 3, right? Distance from x to the origin bigger than 3. So, x cannot be anywhere from 0 to 3. X could be right here, right? It's 3 point something. The distance is bigger than 3. So any point start from 3 all the way to the right is good. But strictly bigger than 3. So we are not including 3. So I'm using open dot right here. But this is not everything yet. It's only for the right hand side. And similarly, things work symmetrically on the left hand side. So if x is somewhere right here, say negative 4 point something, and absolute value, I mean the distance is going to be still bigger than 3, right? You can go as close to 0 as negative 3 right here, and all the way to the left. You see, any value of x smaller than negative 3, or any value of x bigger than 3 will satisfy the inequality right here. So actually, in this case, you guys are going to have 2 separate intervals, or 2 separate inequalities, and you guys cannot combine them together. So you're going to write this way: x is less than negative 3, or x is bigger than 3. Okay. And the interval notation for this is negative infinity to negative 3, or this is what? 3 to infinity, use parentheses. Okay? Now, that's good enough to demonstrate the probability of absolute value greater than something. However, to make sure that everyone get it, let me give you one more example. This time I'll make it a little bit more complicated. All right? What if you have this? Absolute value of 2x minus 1 over 3. absolute value to be greater than 1. This is absolute value, right? Greater than 1. So the number inside the absolute value is not a single x anymore. It is a fraction. And the idea we tackle is going to be the same way, exact same way. Just a bigger fraction, we got to do more work. So this means what? The distance from this fraction right here, 2x minus 1 over 3, to the origin, got to be bigger than 1. It means what? This is a number line right here, 0 right here, 1 right here, negative 1 right here. 2x minus 1 over 3 is going to be to the right-hand side of number 1. Or 2x minus 1 over 3 is going to be to the left-hand side of negative 1. Okay? Because what? The distance from the number to the origin is going to be bigger than 1. This distance from here to here is 1. The distance from here to here is 1. So it's going to be left-hand side of negative 1 or right-hand side of 1. Okay? And same idea. It's right here. And that means what? 2x minus 1 over 3 is going to be less than negative 1. Or 2x minus 1 over 3 is going to be greater than positive 1. Okay? And again, I'm trying to help you to understand it instead of just memorize a little trick to get it, because when I grade your paper, back to a normal face-to-face class, people try to memorize trick, and you used to people confused with the inequality or calculate incorrectly. But I always use a graph to make sure that you guys really understand the problem and you can do it in the proper way. Okay, so we can solve this. I multiply both sides by 3. Or we have 2 inequalities. Okay, 2 separate inequalities. Multiply both sides by 3. It's positive, so we won't change the inequality. So 2x minus 1 is going to be less than negative 3. I time both sides by 3. And then add 1 on both sides, 2x less than negative 2. So x is less than negative 1. Multiply both sides by 3. In this case right here, 2x minus 1 is greater than 3. Add 1 on both sides, 2x is greater than 4. So x is greater than 2. So for interval notation, this is from negative infinity to negative 1 parenthesis. And this one is parenthesis 2 to infinity. Okay. And I think it's a good time to stop section 1.6 right here. We're almost done. Let me cover the very last section for the week of the first week of our course. I'm gonna talk about section 2.1. And actually, the last section, 2.1, is much shorter than what we've been through so far. Okay, 2.1. We're into chapter 2. In chapter 2, talk about coordinate system. In the first section of chapter 2, 2.1, I'm gonna recall or introduce 2 formulas to you: the distance formula and then the midpoint formula. Okay. So before we get to the formula, let's recall something called the rectangular coordinates, or the Cartesian coordinate. The Cartesian, right? To honor a French mathematician, Descartes. Okay, so its origin right here. This is the x-axis, and this is the y-axis. You guys all know this, all right? Origin right here. So I have 2 points. The first point is at 1, 2. So if you have the coordinate system, you wanna locate the point on the xy plane, you use parentheses right here. Okay, 1, 2. Pay attention to this. We're not talking about interval notation anymore, right? We're not talking about all the value of x between 1 and 2. We are using the same type of notation, but this time in this context, we are talking about like a tuple. Say what? A point on the plane with the x coordinate equal to 1 and the y coordinate equal to 2. All right, you guys know that, right? 1, 2, 3, 4, 5. How about 1, 2, 3, 4, 2, 3, 4. Okay. How about the second point? Is at what? 1, 2, 3, 4. Oh, just 5, right? I say 5. Right, 6, 5. So this point is at 5, 4. 3 right here, 4 right here. Okay. See how we locate the points on the xy plane? We need two things, the x coordinate and y coordinate. Later on when you guys study about like three-dimensional straight calculus, you have what? X axis, y axis, and on the z axis you got three coordinates, x, y, and z, but for now just two. Okay. Now you get the coordinate system, right? Points. Now if you have 2 points, let's talk about the first formula. Can I calculate the distance between the 2 points? Let's call the distance d. What is d equal to if you know 2 points? Okay. So number 1, distance formula. Distance formula. How do you find the distance between the 2 points if you know the 2 points on the plane? The idea comes from the Pythagorean theorem, a very famous theorem, as you guys, I bet all of you guys, most of you guys heard before. Okay, let me show you. If I draw a horizontal line from the first point, you guys see that we are having a right triangle, okay, and the distance d right here is the hypotenuse. So if you know this side right here, you know this side right here, let's go, this is A, this is B, and we can use the Pythagorean theorem, say what? D squared is going to equal to A squared plus B squared. And usually people do know C for the hypotenuse, but when we talk about distance, I'll use D instead for distance, okay? So if I know A, I know B, then I would be able to calculate the hypotenuse, and then I take square root to have the answer. So how do I calculate A? A is distance from 1 to 5. How long is that? 4, right? Really, 4 comes from 5 minus 1. Okay, that is A. 4. And what about B? B is from 2 to 4. How long is it? How far is it from 2 to 4? Is that 2, right? This is come from 4 minus 2. So 5 minus 1 squared is A squared plus 4 minus 2 squared is B squared is equal to D squared right here. And of course, plug in the number. This is 4 squared plus 2 squared. 4 squared is 16. 2 squared is 4. And this is D squared. And then you take square root, equal to 20. Right? So D is square root of 20. Okay? And that actually gives you the hint to find out the formula. The formula is similar to what you have right here. So let me write down the formula. I want to save this to the right formula, but I'm running out of space. So let me, let me erase it. Okay, you got this right. So let me write down the distance formula in general. Given 2 points, say x1 comma y1 and x2 comma y2, the distance, say d, between the 2 given points is determined by or calculated by d is equal to square root, right? And this is really d right here. This point right here is x1, y1. But this is x1 right here. This is x2 right here. This is y2 right here. This is y1 right there, right? So what? x2 minus x1 square, we're talking about a square right here, plus y2 minus y1 square, okay? And then you take square root, right? This is the formula to calculate the distance between the 2 given points. Box of that on the plane. And that is the first formula. And then later on in the homework, pretty much I claim that most problems is pretty straightforward. They give you 2 points, they ask you to find a distance, or they give you 3 points and ask you to find a couple